Welcome back. We're writing linear equations in point-slope form. Now, in the previous video, we were given the slope of the function and the function evaluated at 1 point. Here we're not going to be given the slope, but we're going to be given the function evaluated at 2 points. And just like when we're dealing with linear equations in point-slope form, we're going to handle functional or linear functions in the same manner. So let's go ahead and get started. Let's say we have f of 5 equals 3, and f of minus 5 equals 3 halves. Okay, so what did we do back in our point-slope form when we were given 2 points? Well, first of all, we're going to identify our 2 points. We have x equals 5 and f of x equals 3. And this point is x equals minus 5 and f of x is 3 halves. Well, we use these 2 points to find our slope. That's actually what we need to write it in point-slope form. So let's go ahead and find our slope. We should be fairly good at this by now. We have 3 minus 3 halves. We're taking the difference in the y-coordinates and we're dividing it by the difference in the x-coordinates. Just make sure if this is point 1 and this is point 2, you want to treat both x and y as the same. You don't want to say 3 minus 3 halves and then go the other direction, minus 5 minus 5. Okay, you want to go in the same direction. So this is point 1, this is point 2. So denominator, we have 5 minus a negative 5. Always being careful with our signs. Let's go ahead and cancel these negative signs. We can convert 3 into 6 over 2. That way we have common denominators here. We can go ahead and subtract these. So 6 over 2 minus 3 over 2 is 3 over 2 divided by 10. We can write that as 10 over 1. So we can actually flip the denominator and multiply to get our slope here. So we have 3 times 1 is 3 and 2 times 10 is 20. So our slope is 3 over 20. Okay, so now we have our slope and we have 2 points that our function passes through. So we just need one of them. We need to pick one of the 2 points to plug into our point-slope form. Let's go ahead and use this one because they're both positive and neither of them are fractions. So let's go ahead and write our equation or our function, in point-slope form. So we have f of x minus f of x naught, which is 3, times our slope, which is m, it's 3 over 20, times x minus x naught, which is 5. Always write what we're substituting into our function in parentheses, and then we can evaluate the parentheses in the next step. F of x minus, this is just 3, equals 3 over 20 times x minus 5. And that is our linear function in point-slope form. Okay, so we should be very familiar with this because we did quite a few of these in point-slope form when we're given 2 points. We just need to realize that our functional evaluations are in fact 2 points. So let's do a few more of these. Let's say we have f of 5 over 4 equals 5, and f of 7 over 4 equals 6. Okay, so we have 2 points here. We have the point 5, 4 and 5, and we have the point 7 over 4 and 6. Okay, so we have 2 points here. So let's go ahead and plug them into our slope formula to find the slope of our function. So we have 5 minus 6 divided by 5 over 4 minus 7 over 4. Don't get excited about all the fractions. We know how to deal with this. So we're subtracting a 6, so it's the same thing as adding a negative. So we have minus 1 divided by, this is just a minus 2 over 4. Next step, we can write this as minus 1 over 1. We can simplify this as 1 half, so 1 over 2. And if we flip that, we get a minus 2 over 1. We're simply dividing by a rational number, so we're multiplying by its reciprocal. And we also simplify it in the same step. Hope that didn't confuse you. And then we have minus 1 times, we can just write this as minus 2, which is just a positive 2. So we have a slope of 2. This is our slope. Now we need to pick one of the points. It actually really doesn't matter here. And we can plug in one of the points and our slope into our point slope form. So we have f of x. Let's go ahead and use this one. So we have f of x naught, which is 5, minus 5, equals our slope, which is 2, times x minus x naught, which is 5 over 4. 5 over 4. Let's go ahead and evaluate the parentheses that we plugged in. This is just simply minus 5 equals 2 times x minus 5 over 4. 5 over 4. And that's our linear function in point slope form. Alright, so let's do a few more of these. Let's say we have f of 1 equals 7 and f of minus 1 equals 11. Okay, so let's go ahead and identify our points. We have the point 1, 7, along with the point minus 1, 11. So let's go ahead and plug these into our slope formula. So we have 7 minus 11 divided by 1 minus a minus 1. We can add a negative here. We can cancel these negative signs. So we have minus 4 divided by 2. And this is simply a minus 2. So minus 2 is our slope. Let's go ahead and pick one of the points. Let's pick 1 and 7. This has a negative sign in it, and 7 smaller than 11, so this is just a little simpler to work with. So we have f of x minus f of x naught, which is 7, equals our slope, which is minus 2, times x minus f of x naught, which is 1, or excuse me, x naught, not f of x naught, and we can evaluate it, f of x, to write our general form, minus 7 equals minus 2 times x minus 1. And that's all there is to it. Not a whole lot to these point slope form, especially given we've had plenty of practice. So let's go ahead and practice a few more with the functional notation. Let's say we have f of minus 2 equals 0.25. And we're also told that f of minus 3 equals 4. Let's go ahead and identify the 2 points that our function passes through. So x equals minus 2, f of x equals 0.25. Let's go ahead and write that in a fraction form, 1 over 4. And our second point is x equals minus 3. When x equals minus 3, f of x equals 4. Alright, so we have 2 points. Let's go ahead and find the slope of our line. So we have 1 over 4 minus 4. We can go ahead and write that as 16 over 4, just so we can subtract in the next step. 16 over 4 is the fraction form of 4. In the denominator, we have minus 2 minus a negative 3. Okay, we can add a negative here. We can cancel these 2 negative signs just to clarify things a little bit. So in the numerator, we have a minus 15 over 4 divided by 1, or simply minus 15 over 4. So we have our slope of our function. Let's go ahead and pick one of the points to write our point slope form. Let's use point 2 because there's no fractions in it. So we have f of x minus f of x naught, which is 4, equals our slope, which is 15 over 4, times x minus x naught, which is minus 3. Be sure to write our negatives in parentheses. This is actually why we do this step, just so we don't make any mistakes. I tend to lose negative signs. So we have f of x minus 4 equals minus 15 over 4, which is our slope, times x We can cancel these two negative signs, so we have x plus 3. And that is our final point-slope form for our linear equation. All right, let's squeeze in a couple more. Just for a little more practice, we have f of 2 equals minus 4, and we have f of minus 4 equals minus 2. Okay, let's go ahead and identify our 2 points. We have x equals 2, f of x equals minus 4, and we have x equals minus 4 for our second point, and f of minus 4 is minus 2. Okay, so let's go ahead and plug these into our slope formula. We have minus 4 minus a negative 2 divided by 2 minus a negative 4. Really see why the parentheses are helpful here. So our negative signs don't run into each other. So we can cancel these two signs and these two signs. Excuse me. So we have minus 2 divided by positive 6, which is a minus, in simplest terms, is minus 1/3 for our slope. All right, so let's pick a point. This one has one less negative sign in it, so let's use this one. So we have a slope and a point, so let's write our linear function in point-slope form. So we have something like this. We have f of x minus f of x naught, which is a minus 4, equals our slope, which is a minus 1/3, times x minus x naught, which is a positive 2. And that gives us f of x. We'll cancel these two negative signs, so we have f of x plus 4 equals minus 1/3 times x, and this is just minus 2. Okay, so I hope you can see the importance of doing this step. Writing whatever we're plugging into our point-slope form, we're putting in parentheses so we don't lose any minus signs. Okay, extremely, extremely important. All right, let's squeeze in one more. Let's say we have our function is evaluated f of 0 equals 0. This is important because this tells us that the line goes to the origin. X equals 0, f of x equals 0. We also have f of 14 equals 14. Let's identify our points. This is the origin, and x equals 14, and f of x is also 14 in that case. So let's go ahead and find the slope of our line. Should be fairly simple because whenever the line goes through the origin, it makes everything much simpler. I like dealing with zeros. So we have 0 minus 14 divided by 0 minus 14. This just gives us a minus 14 divided by a minus 14, or just, if we cancel these two negative signs, our slope is 1. Okay, we just need one point now that we have our slope to plug into our point-slope form and write the general function. Let's go ahead and use the origin just because it's going to simplify things very nicely. So we have f of x minus f of x naught, which is 0, equals our slope, so 1 times x minus x naught, which is 0. All right, the zeros are going to come in very handy right here because all we're going to have is f of x equals, well, just x. This is the point-slope form of our linear equation, which actually makes sense because it goes through the origin. So we saw something like this in a previous section where it ended up just being y equals x. Now, we can remember to check our other points, but remember that point-slope form will actually always simplify to the same slope-intercept equation, or the slope-intercept function, regardless of which point we use. So if we picked point 14, 14 to plug into our point-slope form, we will definitely not get something that looks like this. It would have more numbers in it. But if we solved both equations for y, or in this case, using functional notation, we solve both equations for f of x, we would actually get the same answer, if that makes sense. So actually, I'll leave you that to practice, just to make sure that you fully understand that both points because they're on the same line, that they'll both simplify into the same slope-intercept equation, no matter how different they look in point-slope form. So look over these a few times, and I'll see you soon.